All
right, here we go. So let's go. We are going to do step into crocodile.
Do not attempt this question for operating.
Yeah.
A motor vehicle. Maybe something confused. Roller. Related.
Number 5, a water tank is in the shape of a hemisphere. So water tank is in the shape
Why would you draw like that?
What do you mean? This is the way it's drawn.
Why would you draw it like a bump? Oh.
This is as good as it gets, man.
That's like a ball. Why would you call it? Yeah.
So we have a hemisphere like this. Water is full here. And it's shown in the diagram. The water is being pumped into the tank at the rate of 45 pi over 2. Water is being poured into there.
45 pi over 2.
Okay, EBDT is 45 over 2. A, what volume of water will the tank hold when it's full? This is 10 feet. So when it's full, it's half of a sphere, right? A sphere, the volume is what? 4/3 pi r cubed. So a hemisphere would be half of that, right? Because it's only 1/2 of it, right? And so r is going to be equal to 10, 2,000 over 3 pi. Okay.
That was it.
R is equal to 10.
Oh, good.
Okay, we're good. All right. Okay. I hope you didn't leave your brain at the bathroom. B. How long will it take to fill the tank?
5.
Think about it. It's going in at this rate, right? So 2 times, I don't know how many minutes, and it'll be full when it reaches that.
Simple.
It's pretty simple, right? So it's going to divide this guy by 45 pi over 2. And that's going to be your answer, right? I mean, you can go further if you want. 3 times 45 over 4,000, whatever that may be. Do I have an answer to that? I should have an answer to that. 29.629. Actually, it's repeated. Do we even want to go there?
No.
On this? Can anybody express this in fractions for me? 620 what?
629 over 9.
There you go. 629 over 999. Good work. Okay. All right. So that's that. And when we fill the tank, that's how we would see. How fast is the water level rising when the water is 5 foot deep in the center? Okay, so here we go. This is where this is the hard part, right? This is the actual. Now we're going to talk about the problem. So when h is equal to 5, we'll call this guy here h. And when h is equal to 5, we want to find what do we want to find? We want to find dHdt, because we're trying to find this guy, okay? But we are given V is equal to pi h squared VR minus what? 3. Okay, this is what it's going to look like. Okay, so given this, okay, so somehow we need to tie R and H together and make this all into H's, correct? Wouldn't that be nice if we could do that? If we could do that, that'd be nice, right? So what do we know here? We know. Anybody tell me what this length here is?
And
It's 10, it's the radius, right? Same radius, right? From here to here, it's the same radius. This here is 10. We're gonna call this guy R and H. Because that's where the R and H comes from, right? What is this guy here? Because the same thing here, this is 10, from here to here is 10. So this guy's gonna be 10 minus H. What is this guy here? R, right? This is R. So I know that R squared plus 10 minus H squared is going to be equal to 10 squared. Okay, so this is what ties the R and the H together. If I take the derivative 2d of 2r dr dt to 10 minus H dH dt is equal to, what's on this side? Huh? Nothing. 0, right? Which is 100, just a number. Take the derivative of 100, 0, right? Divide by 2. Okay. What is R? Do I know what R is?
Yeah.
What is R? R is 10, right? R is 10, okay. Okay, so R is 10. dr dt plus 10 minus H is equal dH dt is equal to 0. If I move it over, which is basically H minus 10. Can you see that? Right? We're good with that? Right? Because I just switched the negatives, right? Okay. So here we go. So let's go ahead now, take the derivative of this. We still haven't, we're pretty close here, right? dr dt is going to be this divided by 10, correct? And that's what we're trying to find. We're trying to find the relationship between dr dt and dh. So we're there here, okay? So dv dt is equal to pi over 3. These are just numbers. And then I have this guy times this guy. So I have to do the, well, product rule, right? I have to do the product rule. So I'm going to take the derivative of this guy first. 2h dh dt, 3r minus h plus h squared. Now I'm going to take the derivative of this guy, which is what? With respect to h, right? Oh, with respect to t. I'm sorry, with respect to t. What am I going to get? This guy stays the same. I'm going to get what? 3 dr dt minus dh dt. Correct? And obviously there's a larger bracket here too. Okay. So now let's go ahead and use this. pi over 3, 2. Do I know what h is? H is given to me as what? 5, wasn't it 5? Right? Wasn't it 5? And we are now trying to find what? We're trying to find dH dt. -30 minus 5, is that correct? Does not sound right. Okay, we got that, we're there, we're good with that, we're good with that. We're good with that, take the derivative of that, blah, 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 blah. Okay, so this guy here so here are DRDT of somewhere. Oh, okay. So this is 5. When this is 5, when h is equal to 5, what is r? Yeah, square. So it's about 5 root 3, right? Right. So r is going to be equal to 5 root 3 dr dt plus this was 5, right? H is equal to 5. dH dt is equal to 0. 5's cancel out. So dH dt is going to be equal to negative dr dt. Right? So we put that in here. What do I get here? So we're going to leave the dH dt because we're trying to find is that what we're trying to find? dH dt? Right? dH dt is what we're trying to find. So we want to leave this. This was 5. 3r was this. 15 root 3 minus 5 plus 5 squared. This guy was this. Right? And multiply by 3, so I'm going to get minus root 3 dH dt minus dH dt. And I know this guy is what? 45 pi over 2. Ta-da! You have one unknown. I'm not going to go through the whole thing. If you go ahead and clean all that up, you get that dH dt is equal to 0.3. Okay. You do all that. I know you get up to you guys. I'm not going to do it. You're going to get 0.3. Okay. That was number 5. So how was it? Can you see that? Can you see how the complexity of the question just was ratcheted up one more level from kangaroo?
Yeah, we have to find R.
It's like,
Can you feel the heat there? Can you feel the heat a little? Okay.
and then it just kept going.
Let's do one last one. Let's do one more. Do one more. Do one more. Let's do number 10.
Why do they call it a hemisphere? It's clearly a bowl.
Yeah.
I guess a bowl is like. Bowl.
You are correct. It is a bowl. All right, let's do number 10. Let's go all the way to the back. We'll do number 10.
That would be the hardest.
That in theory should be the hardest one, but it's actually not the hardest one. So, number 10. Thanks very much. Water is draining from an inverted conical tank. And so we're going for that.
Oh, there's multiple.
So now they use the right word.
Inverted tank. Water is dripping into a
Oh, who came up with this?
cylindrical tank. Is dripping into the cylindrical tank. Okay, so the conical tank has a height of 12, base diameter of 8. So 12, so this would be 4. Okay. What?
You guys who wrote this, no, they had no crap. Because they would have given a crap by describing the shapes. What the heck?
The base of the cylindrical tank has an area of 40 pi square feet. So this is going to be what? 20, right? 20, and the depth in H feet of the inverted conical tank is changing in a rate of H minus 12. Okay, so here, this is a new one. We've never done anything like this. It says that the dH dt of here, right? So we'll call this H. We'll call this guy H. dH dt is equal to H minus 12. So it actually gave you an expression instead of a number. Okay. All right. A. So conical tank is A. How much water does the inverted cone hold when it's full? That's easy. That's nothing more than the volume of this, right? So we can do that. A, that's the volume of the cone, right? The volume of the cone is equal to 1/3 pi r squared times h. No takers? 54 pies? All right. B, write an expression for the volume of the water in the inverted conical tank as a function of H. So I want to know the volume of the water as a function of H. So this is 12 to 4, which just says that this is H, so this is going to be what? 12, 1/3 of it, right? 1/3, that's 1/3. So this guy's going to be H over 3. So the volume is going to be pi r squared times the height, right? Okay. And okay, we'll go with that. And then C. At what rate is the volume of water in the conical tank changing at the instant when H is equal to 3? So they want to know the dV/dt when H is equal to 3. Well, I have the V right here, right? So it's going to go to pi over 9 H squared dH dt. H was what? 3. 3. dH dt was what? H minus 12. minus 9. Right? This that cancels out. Minus 9 pi. So it is decreasing 9 pi a minute, right? Or second, or whatever that may be. Okay, so that's that. D, let Y be the depth in feet of the water in the cylindrical tank. Bottom one is on the bottom down here. Okay, at what rate is Y changing when H is equal to 3? So when H was equal to 3, H is up here. We already found that out. When H is equal to 3, right? I'm getting 9 pi. The volume that's coming down from here is going to be, it's draining at negative 9 pi, which means that the volume being added into here is what? 9 pi. Right? So you're adding the volume at 9 pi at a time per second. So what's the volume here? The volume of the cylinder is equal to what? 20 squared pi r squared times h, right? Or y, because the height here was y, right? Right? So y, so we're at 400 pi y. dv dt is equal to 400 pi dy dt. And we knew that this was 9 pi. So what was the question? The question was, what is dy dt, right? dy dt. So dy dt is going to be nothing more than this divided by 400 pi. Pi's cancel out. 9 over 400. So you could have theoretically figured this out. The only sticking point that you guys might have had would have been this guy right here. How to kind of express that. I mean, I think tying this to this was not that hard. But I think, again, this would have been the sticking point.
That one seemed a lot easier than the other.
Thank God, huh?